All right, in your next review lesson, we're going to review functions, which a lot of this you can go back and look at your 4.2 notes. I do need you to watch this video though, because there are a couple things towards the end that are important that you have probably forgotten about. Okay, so first we just need to review functions. There's a difference between an equation and a function, and it's a very simple difference. An equation would look something like this: y equals 2x plus 1. This is an equation. Whereas a function replaces the y with f of x. Okay. And remember that the variable inside your parentheses must match your variable over on the right side. Okay. F can be different. Maybe that was g of x equals 2x plus 1. Maybe it was h of x equals 2x plus 1. All of those are functions, the f of x, g of x, h of x part. Okay. If our equation was y equals 3t plus 7, then our function would be something like f of t equals 3t plus 7. Okay. So it's just that makes it function notation. Whatever is inside your parenthesis matches over here. So with that in mind, we're going to start evaluating our functions, which you've done before, like I said, back in 4.2, and you've done it a couple of times since then. So first example, we're going to use the function f of x equals 3x plus 1 to calculate f of 5. Well, whatever's in your parenthesis should be your variable that's over there on the right side. So now in our parenthesis is 5. So when we want to calculate f of 5, that means everywhere we see an x, we replace it with 5 because we replace x with 5 right there. So you're going to do 3 times 5 plus 1. Okay. And then you can, use your brains, or you can go to Desmos and you can type that in exactly how you have it right there. So I've got 3 times 5 plus 1. Got Desmos open up here to show you that I can do 3 times 5 plus 1. And there's my answer in Desmos is 16. Okay. So f of 5 is 16. Okay. Another example. Now we're going to use the function g of t is equal to 2t squared plus 3t minus 9. We're going to calculate g of negative 1. So if we want to find g of negative 1, we replace t with negative 1, which means everywhere you see a t, you've got to replace it with negative 1. Now, one thing I want to remind you is we talked about if you have an exponent, you need to put your number in parentheses. So we're going to put negative 1 in parentheses and the squared on the outside. Then continue on 3 times negative 1 and then minus 9. And once again, you can just go straight to Desmos. You don't need to try and work that out on your own. So we've got 2 times negative 1 squared in parentheses for that negative 1 times negative 1 minus 9. I can go to Desmos. I can delete what I've got and I can type in 2 parentheses, negative 1. The squared is on the outside, plus 3 times negative 1 minus 9, and I get negative 10. So g of negative 1 equals negative 10. Okay, it is very, very important that you put your number in parentheses if you're going to have any type of an exponent. So whether that was a squared, a cubed, to the 4th power, to the 17th power, whatever it is, you need to put it in parentheses. And that's true every single time you have an exponent. If this would have had a cubed here, I would put this negative 1 in parentheses and the cubed on the outside. Okay. All right. Now, the next 2 things are things we need to talk about because you're going to see them in your IXLs. A couple things that are just either new or it's been a long time to review. Okay, so it's the same process to begin with, but we're going to talk about absolute values. Remember, absolute values are these absolute value lines, these absolute value bars. So this function says h of x is equal to the absolute value of 3 minus x plus 10. All right, so we're going to calculate h of 7 the exact same way. Everywhere we see an x, we're going to plug in our 7. All right, and you can still go straight to Desmos to do this, but what I want to point out to you is absolute value means your answer must be positive from the absolute value portion. So this part right here, absolute value of 3 minus 7, means I'm going to take 3 minus 7, and then the absolute value means take the positive answer of that. Okay, your final answer could be negative, but the answer of that portion needs to be positive. So if I go to Desmos, I've got absolute value of 3 minus 7 plus 10. So I've got the absolute value bars down here. 3 minus 7. See, if I just stop right there at that portion, the answer has to be positive. Okay, no matter what you make these numbers on the inside, your answer is going to be positive of just that part. Okay, your final answer could be negative. Now I'm going to do plus 10 to get my final answer of 14. Okay, so h of 7 is equal to 14. If my function was h of x equals absolute value of 3 minus x minus 10. Okay, so h of 7 would still be 3 minus 7, but now I make that a minus 10. I want to change that real quick in Desmos and show you how I just make this a minus 10. I can get a negative answer. The only part that has to be positive is the portion inside the absolute value has to end up positive. Okay, but if you just use Desmos to help you get your answers, you should be able to get your answer correctly pretty easily. All right, the last one, oops, not zoom out. The last part we need to talk about are your square roots. Same thing, that you can just use Desmos to help you. So typing these in, plugging them in should be relatively easy. We want to use f of x equals 2 times the square root of x minus 9 to calculate f of 100. So everywhere I see an x, I'm plugging in 100. So I'm going to do 2 times the square root of 100 minus 9. Notice that that minus 9 is not underneath the square root. The only thing under the square root is the 100. Okay, so my recommendation is you still use Desmos to help you with that. You just need to know, if you're not using Desmos, that square rooting means what number times itself gives you 100. Okay, so just real quick, that portion alone, the square root of 100 is 10, because 10 times 10 is 100. Okay, but if we do our entire function, let's come back here, we've got 2 times the square root of 100 minus 9. So I'm going to do 2 times the square root of 100 minus 9, and you want to pay attention. Look at the difference here in that and 100 minus 9. These are completely different functions. This one is the one that we had in our problem because the minus 9 was not under the square root. So this is the correct one. This one is not correct, which should tip you off a little bit that you get these weird funky decimals here. Your IXL is not going to expect an answer like that. Okay, so if you get something like this, you type something in wrong, and it's probably you have the number underneath your square root. So 2 times the square root of 100 minus 9 is equal to 11. So f of 100 equals 11.